Now I've mentioned a couple times about cardinal directions, and by what I mean by that is if we have the sort of a compass rose here, the cardinal directions being north, south, east, and west, and so it's usually pretty easy to determine which is north and which is south, because most people are aware of those. But when sometimes west and east could be confused, so I always think of, if you go clockwise around the cardinal or the compass rose here, we start at the north and never eat salty worms. Of course, I'm sure nobody would want to eat worms in the first place. However, salty ones are probably worse for you. And so anyway, those are the cardinal directions. And when we discuss things like directions of vectors, if we have, for example, we say north, say 35 degrees east. If you see that notation, that will mean that the direction of the vector is 35 degrees east of north. Sorry. So north, 35 degrees east. If we're heading north, and then we go 35 degrees east, we kind of eyeball that and say it's around there-ish. So this would be 35 degrees here. So this is north, 35 degrees east. Another way of writing it could be east, 55 degrees north. Generally though, I think that north and south kind of take priority, and there's more emphasis on those, so you would see the north or the south first before the east and west. So here's another example here. There's the east, and so we could draw a vector like this, and that could be, say, 70 degrees here. So this would be south, 20 degrees east, because that 20 degrees is in here. So it's south, but then 20 degrees towards the east to give that vector, or that angle. Okay, so here's one way of writing directions. We could also say 20 degrees east of north. Actually, let's change that up. Let's say west, just for fun. 20 degrees west of north. So 20 degrees west of north. Again, we're starting at north, and we go 20 degrees to the west. And so here's the 20 degrees here. So that would be 20 degrees west of north. Okay, so those are just a few ways of showing the cardinal directions. When we talk about bearing, bearings start, first of all, they're stated as three-dimensional, or sorry, not three-dimensional, three-digit values, and they always start at north. So the cardinal directions we're going from basically north or south, and then we're taking our angle from there. For bearings, we always start at north. True north is 0, 0, 0 degrees, and then if we're over here, maybe that could be, suppose that angle is a bearing of 0.75 degrees. Okay, and so that would be 75 degrees here. If we were down here, this could be a bearing of 160 degrees. Okay, always starting at 0, or true north. This would be all the way around from here, all the way from north, all the way around here. So that would be a bearing of, let's say, 300 degrees. Okay, so it starts at north, rotates clockwise around until it covers the correct number of degrees, and so it passes 90, passes 180, passes 270 up to the 300. So that was a bearing of 300. Now we'll move on to section 12B, geometric operations with vectors. The goal of this part of the lesson is to learn how to perform mathematical operations with vectors. So with scalars, we've learned how to add and subtract, multiply and divide, among many other operations. We can do similar things with vectors. So if we have two vectors, say vector A and B, we can add two vectors together basically by lining up the head of one vector to the tail of the other. So if we're adding vector B plus vector A, we'll align vector A, the tail of vector A, to the head of vector B. So then this path is shown from the tail of vector B along to the head, and then from the tail of vector A along to the head there. So the resultant displacement, or the resultant location, is going to be vector B plus vector A. So if we went along this path from along vector B and then along vector A, that would be the same as going along this line. There's this vector here, which is vector B plus A. So this is actually a new vector, vector B plus vector A, from the tail here to the head here. One of the I guess characteristics of vector addition is vector addition is commutative, meaning that we could, instead of translating vector A so that the tail of vector A is at the head of vector B, we could translate vector A so that the head of vector A is at the tail of vector B, like shown here. So vector A plus vector B results in vector A plus vector B. So this is a new vector, vector A plus vector B. So these two demonstrate the triangle law of vector addition. Now, if we took this triangle and we placed it on top, so this vector A plus B on top of vector B plus A here, we would then see that this is actually a parallelogram. So this can be the parallelogram law of vector addition, which is just showing the two different possibilities to get the same resultant vector. So vector B plus vector A is the same as vector A plus vector B. So that's one of the characteristics of vector addition. So either using a triangle or a parallelogram. And so one thing to remember is that we add the vectors head to tail. We arrange them head to tail in order to add the vectors together. There is also what's called a zero vector, and if I had vector A and I add the zero vector, well, it's just like in terms of scalars. If I had some value x plus 0, well, I'm just going to get x. So vector A plus the zero vector is going to give me vector A. So we can't add a scalar 0 with a vector because that doesn't make any sense. We have to add vectors together and add scalars together. So in order to establish the idea of 0 in terms of vectors, we have to have a 0 vector, which basically means it's going nowhere. It's not pointing anywhere. So vector A plus the 0 vector gives us vector A. Also, if we had vector A plus the opposite vector A, we get the 0 vector. So if we were to demonstrate vector A here like this, and then we go along negative vector A So if we travel along vector A from tail to head and then travel from the tail to head of negative vector A, we get back to the starting point, which is the 0 vector. So the net distance traveled would be 0.